पर
ठीक है,
सात
ठीक है,
सौ
ओके
साढ़े
ओके।
तीन सौ की फड़े आए मैं 400 रुपये।
काके पता क्या है,
हाँ जी।
आईसीवी च नंबर है, जे रिकनेक्ट करना 500 तक करा देना, बाकी 500 200 फिर करा दी।
इनकम वाले में पहले भी मैं एक दो दिन लोग के पूरे जमा करा दिंदा है, कोई चक्कर नहीं।
हुन किन्ने आ तेरे कोल?
मैं हाफ पवाई को मैं भी हाफ से चला
किन्ने है
साढ़े
वो?
तीन सौ
ले फिर पास 350, बाकी किन्ने कद कराऊंगा? बाकी कितने कराऊंगा?
हाँ जी।
बाकी कितने कराऊंगा?
हाँ लीड है जी, क्या लीड सही है एक्चुअली।
हेलो 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 Hello.
Hello.
Sir, is the class started? Hello. Hello. Hello.
Pankaj Kumar. Pankaj Kumar will first answer your call. Please wait for a while. Pankaj Kumar seems to be busy right now. Please wait. Your call will be answered shortly. जिस व्यक्ति ਨਾਲ संपर्क ਕਰਨ ਦੀ ਤੁਸੀਂ ਕੋਸ਼ਿਸ਼ ਤੁਹਾਡੇ ਦੁਆਰਾ ਡਾਇਲ ਕੀਤਾ ਗਿਆ ਨੰਬਰ ਅਜੇ ਵੀ ਜਾਰੀ पहले अपना खाना फिनिश करो।
Sir, now start your class, sir. Hello, hello.
I think class is not started.
Okay, sir. Thank you.
Record and left to the branch off. Lakshmi, चलो अब करो चलो और अंडी मारो क्या फिर बैटरी क्यों लगी सर बैटरी विजय कुमार जी
What is it?
ठीक है, ठीक है तो अब मुझे ऐसा आइडिया नहीं था ना किसी का। हेलो, हेलो, एम आई ऑडिबल? यार अजय, ओके ओके, थैंक यू। हेलो, हेलो, so welcome again, and in this session we will discuss about this satellite communication, VSAT and DSPT, and so please confirm once again that I am audible to all of you. Okay, okay. So let us start the session. So first we will discuss about this overview of satellite communication. So please tell me that we are using the mobile communication, we are using uh, landline and some other modes of communication. So when all these things are there, then why we are so interested in satellite communication? So nowadays this satellite communication is very, very popular. So can anybody tell me the reasons for this? Hello, 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 hello. I think some issue is there in the sound. Okay, so somebody write in the chat box that it has got wide coverage area, and okay, so basically what is there that so already we are having landline communication, we are having the mobile communication, but nowadays this satellite communication is very, very popular. So if you talk about in the context of India, so 2 or 3 main reasons are there. First reason is that this satellite, it has got the wide coverage. Okay. In fact, if you talk about this mobile network, so in case of mobile, what is there? We are having BTS, BSC, transponder, MSC, VLR, HLR. So much hardware is needed, and we need lakhs of BTS to cover the entire nation. But in case of SATCOM, what is there? With the help of single satellite, we can cover the entire nation. So this is the beauty of the satellite communication, that with the help of single satellite, we can cover the entire nation. Okay. Please just confirm once more that I am audible to all of you. Okay, okay. Okay. So the first reason is that the satellite has got the wide coverage. Okay. And with the help of single satellite, we can cover the entire nation. Second thing is that in case of emergency, suppose some emergency is there, some cyclone is there or some natural calamity is there. So in that case, what will happen? Our landline as well as our mobile communication, it may come down, but the satellite will work. So we can use the satellite in case of the emergency. Some another region is also there that in case of the hard terrain area, like the hilly area, like in case of Himachal Pradesh or Northeast J&K, so where we cannot lay down the optical fiber cables. So very easily, so in that area also we can use the satellite communication. Okay, so these are some regions due to which we are now more interested in the satellite communication. Now there are so many types of satellites are there, and normally the satellites which are used for the communication purpose, so these satellites are known as the ComSat. So you should remember that the satellites which are used for communication, they are known as ComSat. Some orbits are there. I think that is also there in the coming slide. Okay. Now, in case of satellite, what is there? We are having some orbits are there. So if I draw it here like this, so in case of orbit, what is there? We are having LEO. LEO is the low Earth orbit. MEO is the medium Earth orbit, and this GEO is also there. So that is the geostationary orbit. So the satellite, in case of LEO, what is there? The altitude of the satellite from the Earth's surface is less. It means the satellite the satellites which are moving in a low Earth orbit, they are near to the Earth. Then MEO, in case of MEO, what is there? The altitude of the satellite from Earth's surface is between low Earth orbit and geostationary orbit. Now we are having the geostationary orbit. In case of geostationary orbit, what is there? So first thing is the altitude. So in case of geostationary orbit, the altitude above the Earth surface is around how much? That is around 36,000 kilometers. And the time period for the satellite which is moving in case of geostationary orbit, that is equal to 24 hours. Okay. So in case of geostationary orbit, you should remember that first point is that the satellite is revolving. If a satellite is revolving in the geostationary orbit, then altitude will be around 36,000 kilometers and the time period will be 24 hours. Okay, so normally our satellites are moving in case of in the geostationary orbit. But in case of geostationary orbit, what is the problem? That the distance is around 36,000 kilometers. So delay or latency will be more. But in case of LEO, what will be there? As the distance is less, so latency will be less. So in real-time operations, we can use the satellites which are orbiting or which are moving in LEO orbit. So nowadays, we are more interested in LEO orbit. Just a minute. So these are some important lines. These are some important lines for the geostationary satellite. So for a geostationary satellite, the following orbital conditions must be satisfied. First point is that period of the revolution should be same as period of the Earth's rotation, which is around 24 hours. So exactly this is 23 hours, 56 minutes and 4 seconds. The altitude of the satellite should be around 35,786 kilometers. So that comes out to be near to be 36,000 kilometers. The orbit should be in the equatorial plane of the Earth. Okay. And satellite should move in the easterly direction, same as the direction of the rotation of the Earth. So this is the geostationary orbit. So in case of geostationary orbit, what is there? Suppose this is our Earth, and this is a point on the Earth, and this is the satellite. So as the time period of the satellite is equal to the time period of the Earth, that is 24 hours. So a point on the Earth and the satellite, they will always be in line of sight. क्योंकि दोनों का जो time period है वो same है. तो ये point, this point on the earth and this satellite, they will always be in line of sight. ये हमेशा दोनों आमने सामने होंगे. अगर मान लो ये अर्थ घूम करके पॉइंट यहाँ पे आ गया, so at the same time this satellite will be here. So again they will be in line of sight. So we are using this property. Okay, so again I am leaving this point. Now we come to the advantage of the satellite communication. So already I have told you these points, that the large coverage is there. Okay, कि with the help of the single satellite we can cover the entire nation. एक ही satellite से हम पूरे इंडिया को cover कर सकते हैं. So this is the biggest advantage, that we have got large coverage in case of the satellite. Then we are having this high quality is there, na? So basically the factor of the this multipath fading, na? In case of mobile, what we are having, single can travel or single can move on the several paths, है ना? So there will be fading, but this multipath fading effect is not there in case of the satellite communication. So we are getting higher quality. Then high reliability will be there. So once the satellite is launched successfully, then this satellite is going to work for 14 to 15 hours. So reliability will be higher. We are having high capacity will be there. है ना? We are having flexibility is there. Then speed of installation. So यहाँ पे हमें क्या करना पड़ेगा कि कुछ बाकी सब काम तो करना नहीं है, कि आपको कोई एक्सचेंज इंस्टॉल करना है, फिर केबल आपको प्लान करनी है, आपको पावर प्लांट लगाना है. तो यहाँ तो सिर्फ एक सैटेलाइट लॉन्च करना है, एंड आफ्टर लॉन्चिंग ऑफ द सैटेलाइट वी कैन start the service. So speed of the installation will be faster in for the satellite communication. So these are some advantages: large coverage, high quality, high reliability, high capacity, flexibility, speed of installation. Okay. Then emergency communication. In case of emergency, we can use the satellite communication. So these are some advantage of the satellite communication. These are the application area. So in case of telephony, for voice communication, we can use the satellite communication. For satellite television, so nowadays we are having this DTH, direct to home service. So many DTH operators are there. So DTH is one application based on the satellite communication. So we can use it in case of the satellite communication also. Okay. Direct broadcast satellite, we call it as DBS. So this direct broadcast satellite, they are used by the DTH operator. They are used by the DTH operator. We also call it as DBS. Satellite radio is there. So these are the different applications. Then satellite internet. So nowadays, with the help of the satellite which are moving in LEO, low Earth orbit, we can provide the broadband service in the remote area. So that is also one feature. We can also use the satellite in navigation. Na? For example, this GPS, Global Position System. This is also one application based on the satellite communication. So in navigation also, we can use the satellite communication. Now we come to the basic communication satellite component. You know? So what are the different components? So we can understand this through this slide. Na? So normally in case of SATCOM, what is there? We are having two subsystems. So first one is the ground segment. So we are having two subsystems. So first one is the ground segment and second one is the space segment. On the ground segment, we are having the Earth station, na? Or we also call it as hub. So hub and Earth station, they are the same thing. And end user is also available on the Earth. So this is the end user and this is the hub. And in the space segment, we are having the satellite. So this is the satellite here. So from this Earth station to satellite, we are having uplink. And from satellite to this remote user or satellite to this Earth station, we are having the downlink. We are having the downlink. Just like in case of mobile now, we are having uplink and downlink. In the same way, for the satellite, we are having uplink and downlink. So the main component which is available for this on the ground segment is the hub as well as the remote user. And in the space segment, we are having the satellite. At the end of the satellite, we are having transponder. So inside the satellite, we are having transponder. Na? And this payload or the bandwidth is provided by the transponder, which is available in the satellite. So sometimes this is asked in the examination, ki where is the transponder? So transponder is inside the satellite. So the communication satellite essentially consists of payload. So what is the meaning of payload? Payload is the actual bandwidth. And some support subsystem will be there. And this is also written here na, in communication satellite, payload consists of the transponders. Okay. So transponder is inside the satellite and actual payload or the actual bandwidth is given by the transponder, which is available in the satellite. Now, these are some frequency bands which are available for the satellite communication. So actually for satellite communication, we are operating in microwave frequency or gigahertz frequency. So these are some special frequency bands. So normally L band is there. So L band is from 1 to 2 gigahertz. Then S band is from 2 to 4 gigahertz. C band is from 4 to 8 gigahertz. C band is from 4 to 8 gigahertz. X band is from 8 to 12 gigahertz. KU band is there. K band is there. And Ka band is there. Guys, are you able to listen me? Am I audible to all of you? Okay. So these are the bands. Na? L band is there from 1 to 2 gigahertz. C band is from 4 to 8 gigahertz. KU band from 12 to 18 gigahertz. Ka band is from 27 to 40 gigahertz. So out of all these bands, this L band, C band, KU band and Ka band, they are the important bands. है ना? तो ये थोड़ी फ्रीक्वेंसी रेंज थोड़ी आपको ना याद होनी चाहिए ये कि किस बैंड के अंदर कहाँ से कहाँ तक हम लोग मूव कर रहे हैं ये आपको पता होना चाहिए. If we talk about the C band, na, so in case of C band, what is there? Uplink is from 5.925 to 6.425 gigahertz, and downlink is from 3.7 to 4.2 gigahertz. Okay, so this is the uplink. So if you see the uplink, the available bandwidth for uplink is how much? So this is the end point and this is the starting point. So if you okay, I will share the PPT now. I will share this document. So this is the end point and this is the starting point. So if you minus 6 point, if you subtract this 6.425 minus 5.925, so that comes out to be 0.5 gigahertz and this is equivalent to 500 megahertz. So this is the total available bandwidth in uplink and downlink. And so sometimes it is asked in the examination that uplink for C band is from 5.925 to 6.425 gigahertz. Downlink is from 3.7 to 4.2 gigahertz. Okay. So normally in case of satellite communication, what is there? This downlink frequency is less in comparison to the uplink frequency. In case of mobile communication, what is there? Our downlink frequency is more in comparison to the uplink frequency. So right now you should remember all these parameters. Now these are the important lines. One extended C band is also there. Uplink is from 6.725 to 7.025 and downlink is from 4.5 to 4.8 gigahertz. And if we use this extended C band, we can have additional 300 megahertz bandwidth. For KU band, uplink is from 14.0 to 14.5 gigahertz and downlink is from 10.95 to 11.2 and 11.45 to 11.7 gigahertz. So again, the bandwidth is 500 megahertz. So for satellite communication, these frequency bands, L band, C band, KU band, this KU band and Ka band, they are important. इनकी जो frequency range है ये भी थोड़ी आपको पता. It is for vacancy year 202. I don't know which vacancy year I have been told to teach this topic, so that's why I am taking the class. ओके, आई हैव बीन टोल्ड टू टेक दिस क्लास ना। अब ये कौन से वैकेंसी ईयर में है या नहीं है मुझे नहीं पता इसके बारे में। ठीक है, ये आप लोग देख लीजिएगा इस चीज को कि ये है सिलेबस में या नहीं है। जो मुझे बताया गया वो मैंने बता दिया आप। हाँ, या इट इज इन ईबी मॉड्यूल ना गाइस, दिस इज पार्ट ऑफ ईबी मॉड्यूल। Now we come to this time delay issue in satellite communication. So again, we have seen the advantage of satellite communication, but this is the disadvantage of satellite communication. Sir, why uplink frequency is more than downlink in case of satellite? Okay. Actually, what is there na ki in case of satellite, what is there that satellite is somewhere in the space, and in case of the satellite, the main source of the power is the solar power. So we have to save the power at the end of the satellite. At higher frequency, we are having higher losses. ठीक है ना? So we have to save the power. So that's why at the end of the satellite, we are moving on lower frequency in comparison to the mobile communication. This is the reason. Now we come to this time delay issue in the satellite communication. So as we know that in case of geostationary satellite, distance of the satellite is around 36,000 kilometers. So distance is more, so there will be delay. Okay. So delay is the issue in case of the satellite communication. So how much delay will be there? Can anybody tell me? If we move from Earth station to satellite, then how much delay will be there? So time equal to distance upon, so time equal to distance upon speed, na? Distance is around 36,000 kilometer and speed is kilometer. Okay. So that comes out to be around 120 milliseconds. This comes out to be 120 milliseconds. So if we move from Earth station to satellite, so there will be a delay of 120 milliseconds. Okay. And if we move from one point, suppose I am one end user and I am transmitting signal towards satellite, then satellite to the Earth station. So how much time will be there? So one way trip will be from end user to satellite, that will be 120 millisecond. Then from satellite to Earth station, again 120 millisecond will be there. So the total time will be 240 millisecond. And 240 millisecond is a very is some time, है ना? So some delay will be there. So this is the problem in case of the satellite communication. That delay will be there. So sometimes they ask the in the examination, so that if you transmit a signal from Earth station to satellite, so how much delay will be there? 120 millisecond. Okay. So you should know this parameter. These are the different. This is part of your EB. This is part of your EB. This topic is part of your EB module. These are the different orbits for satellite communication. So first one is the low Earth orbit. LEO is there, and the altitude is from 150 to 1000 kilometer, and the time period taken by the satellite is 1.5 to 1.8 hours. Then MEO is there, medium Earth orbit, and altitude is from 5000 to 10,000 kilometer, and time period is 3.5 to 6 hours. Then geosynchronous orbit and geostationary orbit. The altitude is 36,000 kilometer, and time taken by the satellite is 24 hours. So you should remember the name of the orbitals, as well as their altitude and time period. So for this geosynchronous and geostationary, time period is 24 hours and distance is around 36,000 km. Okay. So one slight difference is there in geosynchronous and geostationary. So actually, as we know that this Earth is tilted on its axis. Na? Suppose this is Earth. So this is tilted on its axis. Na? This is not like this. Earth is tilted on this axis, on its axis like this. Okay. And if we draw a plane na, in this axis like this, so this is known as the plane of equator. This is the plane of equator. So if the satellite is moving in the plane of equator, then we call it as geostationary orbit. Otherwise, this will be known as the geosynchronous orbit. Okay, so this is the slight difference. If the satellite is moving in the plane of equator, then that orbit will be known as geostationary orbit. This is the satellite footprint. What is the meaning of footprint? Footprint means the coverage. The footprint of a satellite is the ground area that its transponders offer coverage. Okay. And this downlink EIRP, effective isotropic radiated power, is around 32 dB watt at the beam center. Suppose this is one location, na? This is one geographical area. So actually what is there from satellite, now we are having multiple beams are there. So beam will come from the satellite and will strike at the center of this coverage area. Okay. So at this point we are getting higher coverage. Okay. And if we go 3 dB down from this point, so we are moving towards this region. Na? So this area is known as the primary coverage area. So this is the primary coverage area. And again, if we go 3 dB down from this boundary, na, so we will have this area. So this is the secondary coverage area. And again, if you move 3 dB down from this boundary, na, so you will come to this boundary. So this area is known as the tertiary coverage area. So in which area we are getting stronger signal? Primary coverage area, secondary coverage area, or tertiary coverage area? Where we are getting the stronger signal? Write in the chat box. Yes, very good. So we are getting stronger signal in the primary coverage area. Now we come to the satellite Earth station. So Earth station is just like our telephone exchange. No? So this is available on the Earth, and so the Earth station is the transmission and reception terminal of a telecommunication link via the satellite. The main subsystems of an Earth station to have a much higher performance level than those of a radio relay terminal. The simplest of these are the home TVRO system. TVRO means TV receive only, your DTS system. So our DTS system is also one type of the satellite Earth station. And the most complex are the terminal stations used for the international communication network. So these are the components of the satellite Earth station. Okay. So this is the transmit chain, and this is the transmit chain, and this is the receive chain. So at the end of the satellite Earth station, what is there? At the starting point, we are having the baseband information. Then we are using one modem, and with the help of this modem, what we are doing, we are modulating the baseband information as well as our baseband information. The baseband information, it is in kilohertz. Na? For example, I am speaking, na? So I am using the speech signals. So for speech signals, our bandwidth is around 3.1 kilohertz. 3.1 kilohertz. So this is in kilohertz. But after modulation, we are modulating the signal and we are converting this kilohertz range into megahertz. So after this, we are getting frequency signal in the range of, it is mapped in frequency of a signal of megahertz. Then we are having IF amplifier. Then we are having UC. UC is the uplink up converter. U oblique C is the, this is the up converter. Up converter. So with the help of this frequency up converter, we are converting IF into microwave frequency. Then we are having one HPA. HPA is high power amplifier. Actually, what is there if we transmit a signal from Earth station to satellite? So distance is more. Distance is around 36,000 kilometers. So path loss will be there. So to counter that path loss, we have to amplify the signal. So for that, we are using the HPA, high power amplifier. So with the help of this HPA, we will amplify the signal. Then the output of the HPA is given to the transmitting antenna. And from this antenna, signal is transmitted towards the satellite. Okay, so this is the transmit chain. So at the starting, we are having baseband. Then after modulation, we are getting the IF. After frequency up conversion, we are getting the gigahertz or microwave range. Then we are amplifying it and then we are transmitting it. So this is the transmit chain. In the receive chain, what is there? Signal will be received by the receiving antenna from the satellite. So the first component is the LNA. LNA is your low noise amplifier. So the received signal will be very, very weak. So this LNA, it will remove the noise from the received signal and the signal will also be amplified. So here the signal will be in gigahertz range or in the microwave frequency. Then this output of the LNA is given to the DC. DC is your frequency down converter. So with the help of this frequency down converter, we will convert this microwave into IF. Okay. Then this IF is given to the demodulator. And we will demodulate it and IF is converted into baseband. So this is the transmit and receive operation of the satellite Earth station. Sir, why does satellite only transmits 32 dB watt? So I have taken only one example. No, it can be less or it can be more. So many parameters are there. It will depend on so many things. No? This is not fixed. So for the satellite Earth station, now you should remember this HPA type of things. Now, what is HPA? High power amplifier. What is LNA? Low noise amplifier. HPA is used which side? Transmit chain or in the receive chain? हाँ, है ना? तो HPA high power amplifier is always used in transmit chain. LNA is always used in receive chain. Na? This is written here. Na? The receiver amplifier LNA. The transmit amplifier HPA, high power amplifier. Na? So you should know all these things. Now we come to this. VSAT. Na? So VSAT is very small aperture terminal. So VSAT is very small aperture terminal. Okay. So basically what is there in case of VSAT? Na? So with the help of VSAT, what is there that we can use it in two ways. So VSAT can be used to make the voice call. We can make the voice call as well as we can use the VSAT for high speed internet. High speed internet. Okay. तो दोनों सर्विस यहाँ पे पॉसिबल है. We can use the voice call as well as we can use the VSAT for the high speed internet. So you should know what is the full form of VSAT. So VSAT stands for very small aperture terminal. Why very small aperture? क्योंकि इसमें जो डिस्क साइज है ना वो काफी छोटा होता है. जो इसका डिस्क का साइज है वो काफी छोटा है. That is around from 2 to 5 feet. So that comes out to be around 0.55 to 1.8 meter. So disk का size, the size of the disk is small. So that's why we call it as very small aperture terminal. Usage क्या है इसके? We can use the VSAT to make the voice call as well as we can use the VSAT for high speed internet. तो ये थोड़ा आपको याद होना चाहिए. What is VSAT? टिपिकल साइज क्या है 0.55 मीटर टू 1.8 मीटर. Okay. Now we come to the component of the VSAT. So in case of VSAT, what is there? We are having two parts are there. One is the ODU. ODU stands for outdoor unit, and second one is the indoor unit. Okay, so two part is there. ODU, outdoor unit, and IDU is the indoor unit. Just like this, na, ki this is one host computer, and these are the end users, na. So this host computer is connected to the hub equipment, and this hub is connected to the satellite, and satellite is connected to the end user. And from end user to this modem, and modem to the PC of the end user. So this is the way how we are transmitting the packets. So this host computer and the end users, na, they are operated on low frequency. We are operating on megahertz or the microwave frequency in this region only, na. From hub to satellite and satellite to the outdoor unit, we are operating in microwave frequency. At the end point, we are operating on low frequency. Now we come to this outdoor unit, na. So in outdoor unit, we are having the outdoor unit system is specifically optimized for use with the indoor unit, and it consists of. So what are the different parts of the outdoor unit? So it consists of one transmit receive disk. So it consists of one antenna. It consists of the block up converter. We call it as buck. It consists of the LNB, low noise block down converter, and it consists of the feed assembly. I think picture is also given here, no, like this. Like this. So this is the just clearing it, no, like this. So this is the picture of the VSAT. So in case of VSAT, what is there? This part is installed in the open space, sometimes on the roof, na. So we call it as ODU. So this is your ODU, outdoor unit. The part which is installed in outdoor, that is your ODU. And this modem and PC, na, this is somewhere in the office or room, na. So this is the indoor unit. We call it as indoor unit. So if you see the outdoor unit, so the components are like this. Buck is there. Buck is your block up converter. So buck is used to up convert the frequency. LNB, low noise block down converter. It is used to down convert the frequency. This is your disk, na? This is the disk. And these are the connecting cables, na? So usually in case of VSAT, na, we are having two connecting cables. So we are using VSAT for voice as well as for data. So we are transmitting something as well as we are receiving something. So two chains are there. One is the transmit chain and second one is the receive chain. So that's why we are using two cables, one for transmit operation and one for the receiver operation. Okay. Now actually what is there, if you see it very carefully, na, कि ये काम कैसे करता है. So it simply works at the principle of na ray optics. For example, अगर signals which are coming from satellite, we can assume that the signals which are coming from satellite, they are coming from infinity. क्योंकि डिस्टेंस बहुत ज्यादा है, तो बेसिकली क्या सिग्नल ये यहाँ से सैटेलाइट से आएगा और ये डिस्क पे स्ट्राइक करेगा यहाँ पे, ना, इस तरीके से ये, तो ये रिफ्लेक्ट होगा. फिर ये रिफ्लेक्ट होने के बाद ये क्या होगा, इसके फोकल पॉइंट पे जाएगा. फोकल पॉइंट पे हम लोगों ने यहाँ पे ना ये हॉर्न एंटीना यहाँ पे इंस्टॉल कर रखा है. तो फिर ये हॉर्न एंटीना पे रिसीव हो जाएगा. यहाँ से फिर क्या होगा, ये बक के अंदर जाएगा. बक क्या करेगा, तो सॉरी ये तो सॉरी सिग्नल सेटेलाइट से आएगा डिस्प्ले एंटीना, सॉरी डिस्प्ले यहाँ स्ट्राइक करेगा, रिफ्लेक्ट होगा तो ये फोकल पॉइंट पे जाएगा. फोकल पॉइंट पे हम लोगों ने यहाँ पे हॉर्न एंटीना लगा रखा है. हॉर्न के पीछे जस्ट साइड में ना यहाँ पे एलएनबी लगा हुआ है, ये लो नॉइज ब्लॉक डाउन कन्वर्टर. एलएनबी क्या करेगा, जो सिग्नल हम लोगों ने रिसीव किया इन दी माइक्रोवेव फ्रीक्वेंसी, उसको ये डाउन कन्वर्ट करके IF में कन्वर्ट कर देगा। एंड नाउ थ्रू दिस केबल ना इट विल कम इनसाइड द मॉडेम। मॉडेम के अंदर दो पोर्ट है, वन इज द ट्रांसमिट पोर्ट एंड सेकंड वन इज द रिसीव पोर्ट। तो ये मॉडेम के अंदर आएगा, मॉडेम क्या करेगा, इसको डीमोड करके IF को ये बेस बैंड में कन्वर्ट कर देगा। सो दिस इज द रिसीव ऑपरेशन। ट्रांसमिट मोड में क्या होगा, सपोज यू आर यूजिंग सम वेबसाइट ना, तो हियर वी आर हैविंग द बेस बैंड इंफॉर्मेशन। फिर ये मॉडेम के अंदर जाएगा, मॉडेम क्या करेगा, इसको मॉड्यूलेट करेगा और बेस बैंड हमारा ये IF में कन्वर्ट हो जाएगा। अभी ये इंटरमीडिएट फ्रीक्वेंसी है। फिर ये यहाँ से कहाँ जाएगा, ये बक के अंदर जाएगा। बक इज योर ब्लॉक अप कन्वर्टर। बक का बेसिक काम क्या है, फ्रीक्वेंसी को अप कन्वर्ट करेगा। तो ये IF को कन्वर्ट कर देगा माइक्रोवेव फ्रीक्वेंसी में। फिर ये यहाँ से क्या करेगा, ये फोकल पॉइंट से क्या यहाँ पे स्ट्राइक करेगा और ये फिर पैरेलली ट्रांसमिट हो जाएगा टुवर्ड्स द सैटेलाइट। सो दिस इज द ट्रांसमिट एंड रिसीव ऑपरेशन। ये जो कनेक्टिंग केबल्स हम लोग यहाँ पे यूज कर रहे हैं, दे आर ऑफ टू टाइप। या तो ये RG6 होगा या फिर ये RG11 केबल। दो तरह के केबल हम लोग यहाँ पे यूज करते हैं। तो नॉर्मली RG6 केबल हम लोग वहाँ पे यूज करते हैं जहाँ पे ना डिस्टेंस बिटवीन आउटडोर यूनिट एंड इंडोर यूनिट इज लेस देन 40 मीटर। So we can use the RG6 cable. But if the distance between ODU and IDU is more than 40 meter, so in that case we use the RG11 cable. ठीक है? So these are the uses of the RG6 cable. तो RG6 cable क्या है? If the distance between ODU and IDU is less than 40 meter, we can use RG6 cable. But if distance is more, then in that case we have to use the RG11 cable. तो RG11 cable क्या, थोड़ी इसके losses कम होते हैं, less lossy होती है ये। तो we can go up to more distance. So that's why in that case we have to use the RG11 cable. I think clear हो गया होगा आप लोगों को ना? If some doubt is there, you can ask me in the chat box. So if you compare it with your DTH na, so what is the basic difference between VSAT and DTH? If you see the hardware of VSAT and the hardware of your DTH, so what is the basic difference between two? Please write in the chat box. So your DTH is TVRO na, DTH is receive only. So in case of DTH, in place of two cables, connecting cables, we are having single cable. So only single cable is there. Okay. Second difference is that in case of your DTH, na, we are not having buck. So transmitting portion is not there in case of the DTH. Only receive portion is there. So that is the basic difference between VSAT and DTH. So buck is used in transmit side or receive side? Write in the chat box. Block up converter is used in transmit side or receive side? So block up converter is used in transmit side. फ्रीक्वेंसी को हम लोग अप कन्वर्ट करते हैं इन ट्रांसमिट साइड। जब हम चीजों को ट्रांसमिट करते हैं तो वी आर अप कन्वर्टिंग द फ्रीक्वेंसी। ओके। LNB is used in which side, transmit side or receive side? So LNB is used in receive side, low noise block down converter. ठीक है। If we talk that what are the different components available for outdoor unit, ये outdoor unit के पार्ट कौन कौन से होते हैं? तो बक हो गया, LNB हो गया, डिस हो गया, फीड हो गया, है ना, कनेक्टिंग केबल्स, तो दे आर द पार्ट ऑफ द आउटडोर यूनिट। मॉडेम किसका पार्ट है, ODU या IDU? मॉडेम इज द पार्ट ऑफ इंडोर यूनिट। So these are some basic questions. Na? You should know all these things. These are some features of the VSAT like this DLA. Na? DLA क्या है? Dynamic link allocation. So this is the feature of the VSAT. So sometimes it is asked in the examination, what is DLA? So DLA is your dynamic link allocation. What is the meaning of DLA? Which automatically adjust modulation, coding and gain based on the link environment such as during range to achieve the maximum availability. इसका मतलब क्या हुआ कि the schemes for modulation na it will be selected as per the condition of the link. Okay, okay, just a minute, just a minute. DLA के केस में क्या होगा कि selection of the modulation scheme na selection of the modulation scheme will be as per link condition. Suppose you are getting stronger signal, so in that case you will be allotted higher order modulation like this 16 QAM, 64 QAM na. But if you are getting lesser signal, you are getting weaker signal na, so in that case you will be allotted BPSK or QPSK. And this is dynamic, है ना? System will check the condition of the link. If you are getting stronger signal, so you will be allotted higher order modulation. If you are getting weaker signal, so in that case you will be allotted the lower order modulation. So this is the meaning of the DLA, dynamic link allocation. One ATA is also there here, na? In case of this VSAT, ATA is there. ATA stands for analog telephone adapter, है ना? तो ये थोड़ा आप लोग देख लीजिएगा. ATA stands for analog telephone adapter. Basically, what is there? If you see here, na, so the output of this modem is given to the your PC, है ना? तो यहाँ से हम लोग इंटरनेट यूज कर सकते हैं. बट अगर इफ यू वांट टू मेक द वॉइस कॉल, उस केस में क्या होगा? दिस आउटपुट इज गिवन टू द ATA. So ATA is just one sort of protocol converter, na? So this output is given to the ATA, and ATA is connected to our phone. So this is our phone. So if we are making voice call, in that case we have to use one ATA here. ATA, what is ATA? Analog telephone adapter. ये इन लोगों ने it is shown here like this, na, that this is your VSAT, then this is your modem. ये यहाँ इन्होंने एक हब यूज किया है. हब के एक पोर्ट को इन्होंने PC में दे दिया है और दूसरे को इन्होंने ATA को दे दिया है. And your instrument is connected to the ATA. So this thing are shown here. So these are the services offered by VSAT. So mainly used for voice as well as for the high speed internet. वीडियो कॉन्फ्रेंसिंग हम लोग कर सकते हैं, वीडियो स्ट्रीमिंग कर सकते हैं, है ना? डिस्टेंस एजुकेशन में भी ये काम आ सकता है, बैंकिंग में भी काम आ सकता है कि आज की डेट में जो हमारे ATMs हैं जो रिमोट एरिया में काम कर रहे हैं, हिली एरिया में कर रहे हैं, तो दे आर बेस्ड ऑन दिस VSAT टेक्नोलॉजी. ये कुछ एडवांटेज हैं कि अवेलेबिलिटी ना, तो जहाँ भी आपको क्लियर व्यू ऑफ स्काई है वहाँ पे हम लोग क्या कर सकते हैं, वी कैन इंस्टॉल द वीसेट, वी कैन अवेल द सर्विस। ठीक है। डाइवर्सिटी इज देयर, क्योंकि सिग्नल इज कमिंग फ्रॉम द सैटेलाइट, तो इट इज completely independent of the local terrestrial or the wireline infrastructure. So as far as we are getting signal from the satellite na, in open space, we can avail the services. Deployability is easy na, within the minutes or within the hours we can install the VSAT. So this is also one feature of the VSAT. Homogeneity is also there. Suppose two subscribers are there and they are using the same plan. So services for both the subscriber will be same. The quality of service will be same. है ना? So please go through it na. Availability, diversity, deployability, homogeneity. So these are some advantage of the VSAT. Okay, I will come to that point. Then disadvantage in case of VSAT. So the first disadvantage is the latency. So normally we are using the geostationary satellite. So distance is around 36,000 kilometers. So है ना, तो round trip will be of around 500 millisecond. What is the meaning of round trip? Suppose you are here and this is the satellite and this is the end point. So from here to here 120 millisecond, from satellite to this end point again 120 millisecond, and we are round tripping it now. So again from here to here 120, and from satellite to the user again 120. So 120 plus 120 plus 120 plus 120. So that comes out to be 480 millisecond. So that is around 500 millisecond. Okay. So this is the problem, that latency is more. Problem of latency is there. Then some environmental concerns are there. Suppose if you are moving on, so we have seen some bands, na? L band is there, C band is there, KU band is there, and Ka band is there. So out of these bands, what is there? This KU and Ka band, na, they are affected by the rain. So if some rain is there, na, in that case, signal will be attenuated. So we will not be able to receive the signal. So this is the problem in KU and Ka band. You might have seen it that if some rain is there or if the sky is cloudy ना, in that case your DTH does not work. Why? क्योंकि जो हमारा DTH है ना, जो हम लोग घर में यूज करते हैं, they are based on this KU band and this band is affected by the rain. So in case of rain we are not able to receive the signal. So this is also one problem, है ना, environmental concerns. Now we come to this DSPT, Digital Satellite Phone Terminal. So actually what is there, in case of earlier what was there, we were having two type of things. So one is the VSAT, and VSAT is mainly used for voice as well as for the internet. And second thing is the DSPT. What is DSPT? DSPT is your Digital Satellite Phone Terminal. And this DSPT was mainly used for voice. But nowadays we are not using this service. Na? Nowadays this DSPT service has been stopped. We are not using this. And we are working on this VSAT. अब क्योंकि लेकिन ये आपके एग्जाम का सिलेबस का पार्ट है, सो दैट्स व्हाई वी आर कवरिंग इट. तो DSPT इज मेनली फॉर वॉइस है ना। तो यहाँ पे कुछ इंफॉर्मेशन है, ये आपको थोड़ा पता होना चाहिए कि व्हाट इज डीएसपीटी, व्हाट इज द फुल फॉर्म ऑफ डीएसपीटी, डिजिटल सैटेलाइट फोन टर्मिनल। ठीक है, तो ये लुक वाइज और साइज वाइज क्या है, दिस इज लाइक योर वी सेट, दोनों लगभग एक जैसे ही होते हैं। फिर इसके अंदर क्या है कि इसके कुछ ये फ्रीक्वेंसी बैंड है कि जो हम लोग ट्रांसमिट कर रहे हैं, वी आर ट्रांसमिटिंग इन के यू बैंड, है ना। तो दिस इज फ्रॉम 13.75 टू 14.5 गीगाहर्ट्ज, ये रेंज आपको याद होना चाहिए। एंड रिसीव इज फ्रॉम 10.7 to 12.7 gigahertz, 12.75 gigahertz. So this is the transmit side frequency. This is the receive frequency. Okay. Again, one more important point is there that इसका जो hub है ना for BSNL VSAT network, the hub shall be located at the सिकंदराबाद। तो पहले क्या था कि जो DSPT का hub था, it was installed at सिकंदराबाद। सिकंदराबाद is a small town in UP ना। Okay. So for DSPT, you should remember all these points. What is DSPT? What is the full form of DSPT? What is the transmit frequency? What is the receive frequency? You should learn this frequency. And for DSPT, the hub was installed at Sikandrabad, which is situated in UP. DSPT में हम लोग यूज कर रहे थे one satellite and the name of the satellite was NSS6. This is also not part of your syllabus. बट अभी सेटेलाइट ही डाउन हो गया तो ये सर्विस हमारी स्टॉप हो गई है। नाउ वी आर नॉट यूजिंग दिस सर्विस, सो नाउअडेज मेनली वी आर वर्किंग ऑन वीसैट। ये इसका कुछ हब का इन्होंने कुछ पार्ट आपको दिखाया, तो इसमें जो इम्पोर्टेंट चीजें हैं वो क्या हैं, ये थोड़ा आप लोग देख लीजिएगा, है ना। जैसे जो हब के एंड पे हम लोग एंटीना यूज करते हैं, तो उसका जो साइज है दैट इज 8.1 मीटर। तो नॉर्मली हम लोग जो एंटीना यूज करते हैं एट द एंड ऑफ द हब, दे आर ऑफ बिग साइज, 8.1 मीटर, 13 मीटर, 11 meter. So they are of big size antenna. Okay. Then you should, if we talk about this RF path, so RF path consists of the transmit chain and the receive chain. In transmit chain, we are having ULPC. What is ULPC? ULPC is the uplink power control. ULPC is the uplink power control. Then we are having up converter. So up converter are always used in transmit side. Okay. Then we are having the SSPA. What is SSPA? SSPA is the solid state power amplifier. है ना? So all these three things, ULPC, up converter, and SSPA, they are used in transmit side. What is uplink power control? Uplink power control means that suppose this is our earth station. This is our earth station. And this is the satellite. Huh? Suppose this is the satellite. And we are transmitting signal from the earth station towards satellite. So we have to transmit a signal of some certain power level so that the signal can reach up to satellite. Suppose I am transmitting a signal of 12 watt, na? And with the help of this 12 watt, the signal is reaching up to satellite. There is no problem. But suddenly some snowing is there. कुछ रेन हो जा रही है या कुछ स्नोइंग हो रही है, उस केस में हमें क्या करना पड़ेगा? वी हैव टू ट्रांसमिट लेस पावर और मोर पावर। राइट इन द चैट बॉक्स। Yes. So if snowing is there or rain is there, so in that case we have to transmit more power. So this is the part of uplink power control system. System is monitoring the environmental conditions. You know? Some sensors are there. So if rain is there, snowing is there, so in that case we have to transmit more power. So that is the part of the uplink power control. So what is the full form of ULPC? Uplink power control. So if we see the transmit chain, in the case of transmit chain, we are having ULPC, we are having up converter, and we are having the SSPA, solid state power amplifier. Okay, LNA you already know, LNA is your low noise amplifier, and LNA is used in receive chain. Okay. So this is all regarding the overview of the satellite communication. Na? So once again, I am repeating the important points. Na? तो सबसे पहले हम लोगों ने देखा था ओवरव्यू ना। ओवरव्यू के अंदर क्या है, तो आपका ये एडवांटेज ऑफ सैटेलाइट कम्युनिकेशन। एडवांटेज में क्या क्या एडवांटेज थे हमारे पास? एक तो हमारे पास कवरेज था, है ना, कवरेज है, कैपेसिटी है, जिसको हम लोग वी कैन यूज द सैटेलाइट कम्युनिकेशन इन केस ऑफ इमरजेंसी। जो हार्ड टेरेन एरिया है, हिली एरिया हो गया, जहाँ पे हम लोग प्राइमरी सॉरी ऑप्टिकल फाइबर केबल ले डाउन नहीं कर सकते, तो वहाँ पे हम लोग सेटकॉम को यूज कर सकते हैं। ठीक है, ये हम लोगों ने कुछ एडवांटेज यहाँ पे देखे थे। फिर हम लोगों ने डिस्कस किया था ऑर्बिट्स के बारे में कि लो अर्थ ऑर्बिट कौन सी है ना, मीडियम अर्थ ऑर्बिट कौन सी है, जियो स्टेशनरी ऑर्बिट कौन सी है, इसके बारे में हम लोगों ने देखा था। फिर इसके अंदर ये कितने कितने एल्टीट्यूड है ना, हाइट कितनी है इसकी, और साथ में इसका जो टाइम पीरियड है वो भी हम लोगों ने यहाँ पे देखा था। ठीक है, तो ये थोड़ा आपको याद होना चाहिए। फिर हम लोगों ने डिफरेंट फ्रीक्वेंसी बैंड देखे थे यहाँ पे ना, frequency just like your L band is there, C band is there, KU band is there, का band is there। तो कौन सा बैंड की क्या फ्रीक्वेंसी रेंज है, जैसे L band is from 1 to 2 GHz, C band is from 4 to 6 GHz, ये हम लोगों ने थोड़ा देख लिया था। फिर C band के केस में क्या था कि अप लिंक क्या है और आपका डाउन लिंक क्या है, ये थोड़ा हम लोगों ने एक बार देखा था। टोटल जो अवेलेबल बैंडविड्थ है, अवेलेबल बैंडविड्थ, what is the available bandwidth for uplink and downlink in case of the satellite communication? याद है किसी को? So what is the available bandwidth for uplink and downlink? Yes, yes, very good, very good. So that is 500 megahertz। तो ये थोड़ा हमको याद होना चाहिए। ठीक है, then we discussed about the VSAT। VSAT के अंदर क्या, we have seen the ODU outdoor unit, we have seen the indoor unit, then we saw that what are the different components available in ODU outdoor unit। So what are the components available for VSAT ODU? So buck was there, buck क्या है, buck is your block up converter। then we discussed about this LNB, low noise block down converter। okay, this is there, connecting cables are there। okay, so they are the part of the outdoor unit। what is buck? Buck is your block up converter। buck is used in transmit side। what is LNB? LNB is low noise block down converter, it is used in receive side। okay, so you should remember all these sort of things। and then we saw the DSPT। what is DSPT? Digital Satellite Phone Terminal। okay, इसका जो हब है दैट इज इंस्टॉल्ड एट द सिकंदराबाद। फिर हमने यहाँ पे ट्रांसमिट एंड जो रिसीव फ्रीक्वेंसी है इसके बारे में हम लोगों ने देखा कि व्हाट इज द ट्रांसमिट फ्रीक्वेंसी, व्हाट इज द रिसीव फ्रीक्वेंसी इन केस ऑफ द DSPT। then we saw discussed about this ULPC। what is ULPC? Uplink power control, and that is the part of transmit chain। okay, so if you see the transmit chain, so in transmit chain we are having ULPC, we are having frequency up converter, and we are having the SSPA। and what is SSPA? Solid state power amplifier। okay, so these are some important points for satellite communication। okay, then we discussed about the earth station, satellite earth station, no? Satellite earth station। तो यहाँ पे हम लोगों ने देखा था कि जो ट्रांसमिट चेन है उसके अंदर कौन कौन से पार्ट है. तो इन ट्रांसमिट चेन वी आर हैविंग दिस बेसबैंड, देन वी आर हैविंग द मॉडेम, then we are having the IF, then we are having the frequency up converter, then we are having the HPA, high power HPA. What is HPA? High power amplifier. And then we are having the transmitting antenna. Signal will be transmitted from the antenna of the earth station to satellite. So this is the transmit part. In receive part, what is there? So first we are having the receiver antenna. Then we are having LNA. Then we are having the IF part. Then we are having the demodulator. And in the end, we are getting the baseband inputs. So this is the complete summary for this topic. Na? So if you remember all these points, then there will be no problem. Okay. अब यहाँ पे जो इम्पोर्टेंट है वो यही है कि बी सेट के अंदर ओडीयू है, आईडीयू है. ओडीयू के अंदर क्या है, बक है, एलएनबी है, डिस है. फिर ये कई बार आता है कि जो एलएनबी है वो किस साइड हम लोग यूज कर रहे हैं. वी आर यूजिंग इन ट्रांसमिट चेन और रिसीव चेन, तो ये रिसीव चेन में यूज होता है. ब्लॉक अप कन्वर्टर ये ट्रांसमिट चेन में यूज होगा, है ना. HPA high power amplifier we are using in transmit chain. LNA low noise amplifier we are using in the receive chain. Okay. So this is the complete summary for this topic. So if you are having any doubt, you can ask me. Otherwise, this topic is over. How many marks in this topic? ये तो मुझे नहीं पता, बट दिस इज द पार्ट ऑफ योर सिलेबस ना. तो काफी आसान भी है, इजी भी है, ज्यादा याद करने वाला नहीं है इतना. Okay, I will share this document now. I think already PDF is there, so you can go through that. No, I will also share this Word document. Definitely, I will share this. So I think आप लोगों की काफी चीजें क्लियर समझ में आ गई होंगी. जो मैंने आपको जो अलग अलग टर्म्स बताए उनकी फुल फॉर्म क्या है, किस साइड वो यूज हो रहे हैं, ट्रांसमिट साइड या रिसीव साइड, है ना. तो समझ में आप लोगों के आ गया होगा. And I think this is sufficient for your examination. So if any other query is there or any other point is there, so you can ask. Otherwise, I am ending my session. ठीक है भीमराज जी. आई थिंक कि इसको ना मुझे शेयर करने की कोई जरूरत नहीं है. ये ऑलरेडी जो आपका PDF है ना, जो आपको सिलेबस का जो पार्ट है उसमें ये ऑलरेडी है पहले से. ये आपको मिल जाएगा. ठीक है नरेंद्र जी. NPS सर ठीक है. ओके. थैंक्स एवरीबॉडी.
हाँ हाँ हाँ, लेकिन इसमें ये तो बताओ मेरे को क्या। अच्छा, इसमें सब कुछ रेडी है। और इसमें डॉक्यूमेंट का डॉक्यूमेंट तुम डालो। अच्छा, हाँ हेलो, गुड आफ्टरनून एवरीवन, एम आई ऑडिबल? ओके, आप लोग क्या अनम्यूट नहीं कर सकते क्या? प्लीज वेट ए मोमेंट। Actually, I just come to know that I have to deliver the class. So I am uploading the PPT, then I will start my class on broadband multiplay. Isn't it? So myself, Naresh Singh, SD Broadband ALTTC Ghaziabad. I am working in ALTTC since 2014. Before joining ALTTC Ghaziabad, I was working in broadband multiplay Nok Noida. Isn't it? So in this session, we are going to discuss the broadband multiplay. The topic is broadband and multiplay. Written in my means topic, that is broadband and multiplay, but it is single term, broadband multiplay. So broadband multiplay is the project of the BSNL for providing the internet connectivity. Isn't it? So not in a sum, that is the part of the CFA. Broadband data connectivity. Your existing broadband means data connection on existing copper wire as well as broadband connection or data connection over FTTH, fiber to the home. So the FTTH technology, you can say the fiber broadband. Okay, please wait a moment. Please stop. Please wait a moment. हाँ हाँ हाँ, ठीक है। ठीक है, it is shared now. So thank you, Mr. KKS यादव जी. अच्छा एक बार के 1 मिनट. मेरे को वॉइस नहीं मिल रहा इनका, वॉइस नहीं मिल रहा. उनकी नहीं आ रही है, मेरे को कहाँ आ रही है? हाँ. अच्छा. ये कर रहा है, अलाउ करो. ओके, थैंक यू. हाँ.
Hello.
हाँ हाँ प्लीज. ओके.
Hello, sir.
में अलाउ है जो करना हो ज्यादा डिस्टर्ब हो ना तो ये कॉन्फ्लिक्ट कर देंगे.
ठीक है ठीक है. Okay. So in this session, we are going to discuss the broadband multiplay. Broadband multiplay is the project of the BSNL for providing the internet connectivity through our existing telephone line.
Hello, sir.
हाँ हाँ हाँ, 1 मिनट, मैं इसको म्यूट कर दूं जरा.
Yes, sir.
Okay okay. So
Sir,
let's start. Yes please.
your course is related to CM or CFA.
CFA sir.
So what is what is the CFA link? CM link?
Consumer. Yeah, CFA, fixed assets. Basically, you are having the CFA, CM, EB. So this is the part of the CFA. And this project is for providing the internet connectivity through broadband on existing telephone line or through the fiber. So that is the fiber-based broadband services and copper-based broadband services. In this project, these two types of the wireline broadband connection are being provided to our customers. So customer can subscribe the broadband connection on existing telephone line. Then it is the ADSL type broadband. Or he or she can subscribe the FTTH data connection. So the ISP or BSNL need to lay the fiber cable up to the customer premises. So that type of the data connection, that is the FTTH. So before going to discussion in the broadband, we have to understand first what is the broadband. Anyone tell me what is the broadband? पहले हमें आपको समझना पड़ेगा कि broadband क्या होता है.
The speed is more than 2 Mbps.
No sir, actually क्या है, broadband are being provided to our customer under the guidelines of the TRAI, Telecom Regulatory Authority of India. TRAI has issued its guidelines to all ISPs in India in year 2010. And as per the guidelines of the TRAI in year 2010, all data connection having minimum download speed of 512 kbps is categorized as a broadband connection. So before 2004 in year 2000, before 2010 in year 2004, when broadband services initially launched by the BSNL, at that time the minimum download speed of 256 kbps was set by the TRAI and issued these guidelines to all ISPs in India. ठीक है, एक चीज हो गया. Nowadays the TRAI going to issue new guidelines of minimum download speed of 2 Mbps. But अगर आपके एग्जाम में आता तो you have to set minimum download speed of 512 kbps as per the TRAI guidelines. ठीक है. So to provide, listen carefully. To provide such type of the data connection, BSNL started different project. So you have to know the different projects, data NIV project for providing such type of the data connectivity. One is the project 1. आपके document for your study, you should take the base of the document provided by the BSNL. for this LIC exam, LDC exam. Are you getting my point? For
Okay.
ठीक है, तो आपको रेफरेंस के लिए वो डॉक्यूमेंट रेफर करना पड़ेगा, और उसमें जो है इनिशियली लिखा हुआ है कि देर आर 4 मेन प्रोजेक्ट. प्रोजेक्ट 1 MPLS कोर सर्विसेज, MPLS IP MPLS और MPLS कोर सर्विसेज. Project 2.1 that is narrowband services, or you can say the dial-up services before commissioning of the broadband services in year 2004. Individual subscriber was having the feasibility to connect his or her telephone line in inbuilt modem of the PC and dial 172233 or 172222 for accessing the data connection. That types of the data connection termed as the dial-up services or sanchar net services. ठीक है, so that comes under project 2.1. Now this project is absolute. Every person or every data connection is being provided through the broadband. That is the project 2.2. Project 2.2, that is the broadband services, isn't it? Project 3. Project 3 is the OSS BSS project, Operation Support System and Business Support System. So this is the, in this project, in this NIV2 project 3, there are 4 data center. The main data center, NIV main data center is situated in Bangalore. Its DR data center is situated in Pune, and 2 more secondary data center. One is in Noida and other is in Mumbai. So these are the 4 data center in this project, project 3. तो 4 प्रोजेक्ट हो गए. प्रोजेक्ट 1 MPLS core services, project 2.1 that is the narrowband services or dial-up services, project 2.2 broadband services, and project 3 OSS BSS. And the project 2.2, which is the broadband project, is migrated a new project that is known as the broadband multiplay project. Are you getting my point? So in broadband multiplay project, we are providing, or BSNL is providing the broadband services along with the many value-added services like VPN over broadband, IPTV over broadband, VoIP over broadband, and or internet lead line through the broadband network, or all types of the Ethernet connectivity can be provided from the different broadband multiplay network elements working in broadband multiplay network. Okay, so these are the different products. So broadband multiplay project is migration of old broadband project that is 2.2 to the broadband multiplay, isn't it? एक चीज हो गई, different project हो गया पहली चीज. Okay, now we have understood what is the definition of the broadband. ठीक है, you know. So all data connection having minimum download speed of 256 kb, 512 kbps, latest 512 kbps, not 2 mbps, not 256. You have to write minimum download speed of 512 kbps and can reach up to the capability of the network elements of any IS. ठीक है, तो in foregoing session we are going to discuss that the broadband, its advantage, capacity and capability, broadband access technologies, broadband multiplay network. In this session we will discuss the broadband components, broadband network architecture and connectivity of different components, layered architecture, access layer, aggregation layer and core layer, what types of the equipment we are using, and broadband network elements at a glance you have to understand. Okay, broadband components overview and functionality, broadband multiplay services, whatever the services are available on the internet, all types of these services were being provided to the customer through these broadband multiple project initially. Now, if you are having the data connection and you are connected to the internet, you can access any type of the service, any type of the data service available on the internet. Internet services, download content, audio on demand, video on demand, many type of the services we were providing through this project. But nowadays, all these type of the services are available at the internet. Okay. And the customer premises equipment, that is the broadband CP. Okay, practical demonstration will not be possible. We will try to make you understand each and everything related to the broadband. Okay, so please pay attention. एक चीज समझ में आ गई आपको. Now come to the introduction of the broadband. One of the latest trend in enhancing the data communication system involves the broadband technology. Broadband refer to greater bandwidth or transmission capacity of a medium. Broadband technology will allow high speed transmission of voice, video, and data over network like the internet. Okay. So, and always on, why it is called always on? Always on data connection supporting interactive services, including internet access, and has the capability of the minimum download speed of 512 kbps. जैसे मैंने पहले भी बता दिया था, to an individual customer from the point of presence, POP of the service provider, from where the subscriber is physically connected. So that may be the DSLAM or OLT in case of the FTTH broadband, DSLAM in case of the means copper broadband or ADSL broadband. So speed, you know, so please let me know first thing, on what credential the speed of any broadband connection is depend. So every subscriber is having a plan, a specific plan. In technical language, the name of plan is termed as the AAA policy. So on subscription of the broadband service, the subscriber is provided the username and password of the broadband service. From this user ID, the AAA policy or plan is binded. You can say the AAA policy is binded to the broadband user ID, which need to be configured in the CPE. That may be a modem in case of the ADSL broadband or ONT in case of the FTTH. So this username and password need to be configured in the modem or ONT. So this is the comparison chart. As I have stated, the different project, dial-up PSTN, dial-up ISDN, that comes under project 2.1, and internet lease line is dedicated data connection, and project broadband comes in the project 2.2, and that is migrated in broadband multiplay project. So minimum download is 256 in 2004. Initially, when broadband services was started in India, okay, availability it is available everywhere because we are having the telephone line in each and every corner of India. If you are having the telephone line, you can simply subscribe the telephone broadband connection on your existing telephone line, and you can configure the username and password of broadband service after purchasing a modem from the open market. Okay. Internet access, dial and connect. Initially in dial-up PSTN or dial-up ISDN, the voice and data services were not available simultaneously. But after commissioning of the broadband services in year 2004, the broadband and voice services were available simultaneously. So in broadband, you can have voice and data services simultaneously. Okay. So this is the comparison table of dial-up connection, internet lease line, that is the high speed dedicated data connection, now can be provided from the different broadband multiplay network element working in broadband multiplay. Okay, so you have to write what is the broadband. So broadband is the data connection having minimum download speed of 512 kbps, not 256 kbps or not 2 mbps. 2 mbps will be in future, or when the TRA will issue the guidelines to all ISPs in India. Okay. Now, please understand. So broadband multiplay is the project for providing the broadband along with the value-added services. So value-added services, telephone, IPTV, video on demand, internet services, video conferencing, VPN over broadband, and many more. So for segregating, you can avail these type of these services on a single broadband pipe that may be a copper line or maybe a fiber line. So different services are segregated. You know, the voice and data are segregated by the which network element? Which element? Can you tell me?
Broadband.
Broadband and voice. Data and voice are segregated by which network element? You know?
Splitter, sir.
Splitter. So splitter is a high pass, low pass filter used at both end, subscriber side as well as ISP side. So at ISP side, it is inbuilt with the DSLAM. Are you getting my point? And this is a high pass, low pass filter. Please remember. So splitter is a high pass, low pass filter used at both end, subscriber end and ISP end. So it is splitting the voice and data signal. You will learn the many things in DSL technology when it will be taught to you. Okay. So, but other services like IPTV, video on demand, audio on demand, video conferencing, VPN over broadband services are segregated by the different ATM PVC values. Listen carefully. So between modem and DSLAM, there is a protocol known as the ATM, asynchronous transfer mode. So in ATM, there are PVC values, permanent virtual channel values, and these are the two: BPI, virtual path identifier, and virtual channel identifier. So for broadband service 035, for IPTV, it may be a 000, or for VPN over broadband, you know, it may be a 032. So different services, different or multiple services are segregated at modem by their specific ATM PVC values. So the protocol working between modem and DSLAM, that is the ATM. And in case of the FTTH, this is the GEM values, GPON encapsulation method values, or ATM. In FTTH, GPON, ATM, and TDM, both protocol are supported for establishing the connection between CPE and the access network element, that may be OLT or DSLAM. So you can understand the technical definition of the broadband. Broadband is a point-to-point protocol over Ethernet, which uses ATM PVC values to establish logical or virtual connection between CPE and the access network element, isn't it? So you need to remember. So कई बार ये क्वेश्चन आ जाता है, which protocol is used in ADSL technology to establish the data connection between modem and the DSLAM. So that is the ATM. आप लोगों को पता भी है, आप जब ब्रॉडबैंड कॉन्फ़िगर करते हो तो एटीएम पीवीसी वैल्यूज 035 डालते हो, ब्रॉडबैंड का जो बैन लिंक बनाते हैं आप, यू नो, ठीक है, तो आपको पता चल गया। नाउ इसके बाद आपका आ गया, so it advantage of the broadband always on, very fast, starting from 512 kbps can reach up to the 100 mbps and more. It depends on the capability of the broadband network. Like in case of the ADSL, there are 3 variants of the ADSL technology. XDSL का नाम सुना XDSL. X may be A, asymmetric, or X may be symmetric, S, symmetric, symmetrical DSL, symmetrical digital subscriber line, ADSL, asymmetric digital subscriber line, in which it is having more download in comparison of the upload. But in case of the SDSL, same download and same upload. Okay, so further there are 3 variants of the ADSL. It may be ADSL, ADSL2, ADSL2 plus. You may get the answer which is not the variant of the ADSL technology. So there are 3 variants: ADSL, ADSL2, ADSL2 plus. In ADSL, we can provide maximum download speed 8 Mbps and upload speed of 1 Mbps. In case of the ADSL2 plus, we can provide up to 12 Mbps download speed and 1 Mbps upload speed. And in case of the ADSL2 plus, we can provide up to 24 Mbps and 1.5 Mbps upload speed, isn't it? So you need to know the capability of the different variants of the ADSL technology. You may get the question related to the ADSL technology. Okay. And there are 2 variants of the VDSL, very high data rate. VDSL stands for very high data rate digital subscriber line, in which you can provide up to 55 Mbps download speed and 30 Mbps upload speed. But being it being a copper, there are many constraints on the telephone line. Due to the high impedance, due to moisture on the telephone line, or due to the bad weather conditions, the condition of the telephone line may deteriorate, due to which it may be the high impedance. If it is a high impedance, we will not be able to provide the speed as per the plan or as per the AAA policy of the subscriber. The 1 point, keeping in these constraints in the mind, the condition of the line, we are having a parameter, that is the DSL parameter known as the SNR margin, signal to noise ratio margin, which is depending on the condition of the telephone line or condition of the DSL, isn't it? So how many joints are there? What is the condition of the telephone line moisture? Or what is the condition of what is the weather condition? It is a rainy season. So if it is a rainy season and number of joints are more, then the condition will become poorest. And due to poorest, the SNR margin will decrease tremendously. Okay. The second is the SNR margin also depending on the port bandwidth of the subscriber in the DSLAM, as per the plan of the subscriber or as per the AAA policy of the subscriber. Listen carefully. As per the plan, or you can say as per the AAA policy, we create a policy, and that is known as the profile in the DSLAM or DBA profile. DBA profile in the OLT. Profile in the DSLAM It is nothing, but it is a bandwidth need to be created, and attached to the subscriber port. Are you getting my point? So if it is a high speed plan, if a broadband is a high speed plan, so accordingly you have to set the high bandwidth at the subscriber port in the DSLAM. If we are increasing the profile or bandwidth of the subscriber port, the SNR margin will decrease. Listen carefully, the point is clear now. The SNR margin is inversely proportional to the bandwidth of the port. So you can tell the correct answer. अगर क्वेश्चन आता है तो आप बता दोगे तो SNR margin किन किन चीजों पे डिपेंड करता है. One is the line condition, or you can say the DSL condition, and other is the profile or bandwidth attached to the subscriber port in the DSLAM. Okay. Now the second parameter, which is depending on the distance between DSLAM and the modem, that is the attenuation. So attenuation is the how much signal is attenuated, how much signal is attenuated with the distance from DSLAM to modem, known as the attenuation. The value of the attenuation should be 0 in ideal condition. Okay. So it depending in two things. One is the distance and other is the gauge of the DSL or line. टेलीफोन लाइन की जो गेज होती है, जो थिकनेस होती है, उन दो चीजों पर डिपेंड करता है. थिकनेस एंड द डिस्टेंस बिटवीन मॉडम एंड द DSLR. इसकी वैल्यू आइडियली 0 होनी चाहिए. जितना ज्यादा डिक्रीज होगा, जितना ज्यादा एट्यूनेशन होगा, उतना ही DSL नहीं आएगी हमारे सब्सक्राइबर एंड पे. ठीक है. और SNR मार्जिन की वैल्यू मैक्सिमम होनी चाहिए इन आइडियल कंडीशन. क्लियर हुआ? तो आप बता सकते हो, आप करेक्ट आंसर कर सकते हो कि SNR मार्जिन शुड बी मैक्सिमम एंड एटेन्यूएशन शुड बी मिनिमम टू प्रोवाइड द स्पीड एज पर द प्लान ऑफ द सब्सक्राइबर. The point is clear. So this is the very fast speed. So that is the very fast, no disconnection, no additional access charges, telephone and voice data simultaneously. As I have stated earlier, broadband is a service always on data connection which provide voice and data services simultaneously. So there is no additional charge of the simultaneous access of the voice and data services. Fat pipe has to be continuously supplemented with value-added application to enjoy the advantage of this broadband connection. Okay, इतनी चीज समझ में आ गई. Access technology, as I have stated earlier as well, DSL digital subscriber line, that is the copper-based broadband services. मैंने already ADSL, VDSL को बता दिया. These two types of the data connection we are providing to our customers. Cable broadband we are not having, that is the like along with the cable broadband cable services, we can provide the broadband services. Fiber technology, that is the latest, which is the emerging trend of the data connection, that is the FTTH, fiber to the home, fiber to the building, and fiber to the curb. These are the three variant. Power line broadband. So BSNL are fulfilling the requirement of different types of the subscriber in the market by these two technologies, that is the digital subscriber line, that may be the ADSL or SDSL, VDSL, IDSL, in ISDN digital subscriber line, or HDSL, high speed digital subscriber line. Okay, and FTTH. Now this is the wireline broadband DSL. आप लोगों को पता है, this is a wireline transmission technology that brings information faster over copper telephone line. Already you know, पहले ही डिस्कस कर लिया है. DSL exploit the extra capacity to carry the information on the wire without disturbing the line's ability to carry the conversation. इसमें जो है ये मैंने ऑलरेडी बता दिया XDSL के, दीज आर दी वेरिएंट, हाई डेटा रेट डिजिटल सब्सक्राइबर लाइन, सिमेट्रिक सेम अपलोड डाउनलोड, ADSL। एसिमेट्रिक में मैंने आपको 3 वेरिएंट बता दिए, वो आपको याद करके रखना। IDSL, ISDN डिजिटल सब्सक्राइबर लाइन, VDSL, तो यू नो, ठीक है। अब मैंने आपको ये भी बता दिया सबसे ज्यादा डिस्टेंस तक जो है ADSL 2+ प्रोवाइड करा सकता है डेटा कनेक्शन। तो दीज आर दी 3 वेरिएंट। आपको क्या करना है, आई हैव कम्युनिकेटेड 8, 12 एंड 24, दिस इज द कैपेबिलिटी ऑफ आवर प्रोक्योर्ड DSLAM, जो BSNL ने प्रोक्योर किया उसमें 8, 12 एंड 24 Mbps, ठीक है। 640 and 1 Mbps, that is the upstream. Okay. Now, to provide the broadband services, broadband service creation, broadband provisioning, configuration, providing the data connection, or transporting the subscribers' data to the core network, that is the internet, and keeping the database of the subscribers, and keeping the database of the subscriber and providing the secured connectivity, broadband connectivity. There are 3 types of the components. There are 3 types of the component, that is the customer premises, broadband network elements, and the servers. The customer premises equipment you already know, I have already discussed. And the broadband network element, there are 3 types of the broadband network element as per the connectivity and the service they are providing. One is the access network element, that is the DSLAM in case of the ADSL broadband, OLT in case of the FTTH broadband. So these 2 element, broadband network element, DSLAM and OLT, are giving the access through connectivity of the direct connectivity of the subscriber or direct termination of the subscriber to the interfaces available in these cabinets, access network. And the second types of the aggregation network element, which are aggregating the traffic from the access network and switching to the upper network element, or you can say the core network. And the third one is the core network element, that are the router. Access layer पे multiplexers हैं, so DSLAM and OLT are the multiplexer, which are multiplexing the data of all connected subscriber and converting into a composite signal. This composite signal is known as the Q in Q VLAN or outer VLAN of the DSLAM or OLT, you know. Okay. And the second aggregation layer, aggregation network element, these are the switches, which are having the interfaces like FE port, fast Ethernet port, GE port, that is the gigabit Ethernet port, or 10G port, as per the capability of these network element we are having in our network. And other are the ring port. To connect these switches in a ring, we will see the network architecture of these network element in further slides. And the third type of the broadband network element, that are the servers. SSC, the subscriber services selection center. AAA, authentication, authorization, and accounting. And LDAP, lightweight directory access protocol. These 3 servers, SSC, AAA, and LDAP, plays a vital role in providing the secured connectivity, secured broadband connectivity. So SSC is the proxy of the AAA. It is a middleman. It is handling the queries of the subscriber, asking or coming for broadband connectivity. SSC, Subscriber Services Selection Center, is a proxy of the AAA, which is working on behalf of the AAA, which is the Radius server. Radius stands for Remote Authentication Dial-in User Services. So the Radius server was working in project 2.2. Now it is a AAA. Authentication, authorization, and accounting. In this physical server, these three processes sequentially. First, the authentication, the username and password along with the port binding of the subscriber. I will tell you what is the port binding. You need to write in the chat box what is the significance of the port binding and what are the parameters of the port binding. You need to write. So first, the subscriber need to be authenticated. So first process is authentication. Second is the authorization. Authorization means checking the status of the subscriber user ID. Is it suspended due to non-payment or in active state? If it is in active state, how much speed is there? How much speed need to be provided to the subscriber? And how much data download should be available to the customer or subscriber, you can say. And how much and what is the time of the high speed? Up to what time the subscriber will get the 10 Mbps, and after completion of that certain GB data load, the speed of the subscriber set to the as per the plan. We will discuss that is the FUP, fair usage policy of the subscriber. We will discuss. And the third one is the accounting. Accounting means the subscriber usage records should be maintained, which need to be sent for further billing. And LDAP is the lightweight directory access protocol for keeping the database of all broadband subscribers. Means what is the username, what is the password of the broadband subscriber, what is the port binding of the subscriber, what is the AAA policy of the subscriber, and how much speed is binded with the AAA policy. So these things need to be kept intact in this LDAP, which is a protocol, and in our network, it is working as a database, lightweight directory access protocol. Okay, we will discuss further. And DNS, domain name system. If you are connected to the internet, if you want to open any website, so first the request will go to the DNS server, which resolves the name of the website into the corresponding IP address of the web server, and vice versa. So that is the named services are provided by the DNS. And SS, subscriber self services subscription system. So through this physical server, we provide the FUP, fair usage policy, to the subscriber. And differential speed plan subscriber are served by this server, SS server. And you need to know what is the FUP, fair usage policy of the subscriber. So every subscriber which are having the unlimited data download plan can be provided up to 10 Mbps speed in a month, up to certain GB data download. After completion of that certain GB data download, the subscriber page is redirected to a page which is known as the FUP page. From that FUP page, subscriber can top up to maintain 10 Mbps or deny the option, and every activity after confirming the every activity on this portal, the subscriber modem need to be restarted to restore the session again. So these are the, so content based, you can also say the content based services are provided to the subscriber by the SSS server via BNG. So all these server, SSC, AAA, LDAP and SSS server are working in conjunction of the, or you can say the BNG is working in conjunction of these servers to provide the internet services to the broadband subscribers, isn't it? Now come to the next one. So I have already stated access layer. You can overview access layer. Access layer is the one which faces the customer side, and all the access devices such as DSLAM, OLT provide the connectivity to the CPE like modem, ONT or ONU, ONU in case of the FTTH broadband, and modem in case of the ADSL. And set-top box is exclusively required to provide the IPTV along with the broadband connectivity, gates connect. The point is clear now. And aggregation layer, as name depict, this layer aggregate all the access traffic and pass or switch to it to the core or gateway, that is the BNG. Here in the aggregation layer, we have migrated our existing traditional RPR ring and OCLAN switches to the MNG pen, MPLS next generation packet aggregation network. We will further we will discuss. We can see further. Core or gateway, all the aggregated traffic is assigned quality of service, or you can say the traffic policy, and make its way to the global internet via the gateway. So here it is the BNG, broadband network gateway, which is the router, or you can say MSER, multi-services edge router, multi-services edge router, multi-services edge router for providing the access of the multiple services from the BNG. So service specific logical mini router or logical separation is made in the BNG known as the context in the BNG. Like we are having the BSNL.in context for the broadband ADSL layer, ADSL broadband service. FTTH.bsnl.in for FTTH broadband service. BB-ILL for internet lease line context, and so on. So multiple services, multiple context in the BNG. BNG assign the network credential, or you can see the IP address after verification of the username and password and port binding and authorization and ensuring the accounting of the subscriber to the subscriber modem. After completion of the authentication, authorization, and ensuring the accounting of the subscriber, BNG assign a free IP address to the subscriber modem by means of the DHCP, Dynamic Host Configuration Protocol, enable in the BNG. It also ensure the authentication, authorization, and accounting in conjunction of the SSS system. In it enforce the traffic policy to the subscriber system. So these are the main features or virtues of the BNG with respect to the broadband connectivity. Okay, so this is the network architecture. Please listen carefully. Here is the broadband network gateway, that is the BNG. BNG is the network element in broadband multiplay network, which connecting the network element or router in project 1. Listen carefully. Question may be, which is the network element which is connecting the network router of the project 1? So that is the BNG. So BNG is connecting to the P router, provider edge router of MPLS core network, isn't it? Okay. And it is connecting to the tier 1 switches. So these are the netting 10,000 R switches which are working in the ring for providing the redundancy in the network. Now this RPR tier 1, tier 2 switches are going to be upgraded or going to be migrated on the PAN, MNG PAN switches. That is Citran, PAN cow and PAN switches, or Citran 660 and Citran 650. And the distance between tier 1 to tier 2 and tier 2 to tier 2, that is 40 kilometers on dark 5. Listen carefully. Sometime you may get the answer question. What is the maximum distance available between tier 1 and tier 2 switches, or two different tier 2? So that is the 40 kilometers. Our traditional RPR ring is working for the 40 kilometer distance and can support up to unlimited distance if we use the DWDM or STM16 technology. And up to 10 kilometer distance for in-city traffic or the urban traffic, we can connect multiple DSLAM or multiple OLTs. So multiple DSLAM can be connected up to 10 kilometer. Beyond 10 kilometer, for providing the broadband services, we need to connect one more switch that is known as the OC line switch, up to maximum distance of the 40 kilometers, and can connect it up to unlimited distance if STM16 or SDS technology is used for providing the connectivity. From OC line switches, further DSLAMs, OLTs, internet lead line, Node B, Wi-Fi hotspot, BiMax BTS can be terminated. So Ethernet port, FE and G ports are available at the OC line switches. From these ports, we can connect the DSLAM or OLTs as per the type of the connectivity we are having. And from the DSLAM up to 5.2 kilometer, we can connect the modem. Okay. And for fiber broadband connectivity, we can terminate the OLT from any interfaces, FE or G interfaces available at tier 1, tier 2 switches or OC line switches for rural broadband. And from OLT, we can terminate the ONT and ONU. So ONT and ONU are the CP. These devices function similar to the modem in the ADSL technology. Okay. So this is the network architecture. You can go through the customer premise recruitment, that is the XDSL broadband, modem, splitter, set-top box, telephone connection, FTTX. We are having the optical network terminal unit, optical network unit for multiple subscriber, for single subscriber up to the customer. We use the ONT, and for multiple subscriber, we can have the ONU. So this is the network, means the diagram of the subscriber premises connectivity. You can go through, you are doing. So there is no need to further correct. So splitter I have already stated, which split the voice and data signal. Voice signal goes to the subscriber telephone line and data signal goes to the modem. And at the CO side, the voice signal goes to the traditional telephone line and data signal goes to the DSLAM control. So this is the high pass low pass filter used at both ends. Okay. And the CP direct the signal to PC and TV services. Specific ATM PVC values need to be configured. Enable security features to avoid the botnet and man in the middle attack. Very important. You need to ensure the proper security implementation at the modem or ONT site, because we are having our broadband network is layer 2. From DSLAM to BNG, the data traffic flow take place in form of the VLAN. And from the modem to the DSLAM, it is ATM PVC well. So there is very difficult to penetrate and capture and further analyze the data or capture the data with respect to the hacking point of view. It is very difficult. But here at the subscriber side, that is the very vulnerable. Okay. So being the customer interface, direct customer interface, you need to suggest the security policy for WLAN security and BAN security at the subscriber side. You need to avoid this MITM, man in the middle attack. Man in the middle attack can only happen if you have provided the access to the unauthorized person or hacker. By providing the password, or hacker can exploit the password or crack the password to have the connectivity in the wireless network or Ethernet network of the subscriber. So this is the broadband network element, access network element, that is the DSLAM and OLT. I have already stated aggregation switches for transporting the data and switching to the upper network element and aggregating the traffic of the access network. Provision, service provisioning, implementation and configuration. Network element, REST, remote access or BBREST was in year 2, means in project 2.2. But here the REST is replaced. BBREST is replaced by the BNG in broadband multiplay. Listen carefully. So REST, remote access server, that is the router or BBREST working in project 2.2, which is replaced by the broadband network gateway, that is the MSER multi-services agent. Okay. Here the DSLAM, digital access multiplexer or demultiplexer, it is multiplexing all connected subscriber into a composite signal. It supports point-to-point protocol and ATM for XDSL services, support GE and FE connectivity for uplink, one port for uplink connectivity to OC-LAN or Tier 1, Tier 2 switches, and other ports can be used for cascading of the DSLAM and other type of the data connectivity like internet lease line, Wi-Fi hotspot connectivity, by max BTS connectivity, or other types of the Ethernet connectivity. It supports the VLANs. So it is having the ADSL card. So first broadband subscriber in a DSLAM is initial subscriber is having first subscriber is having the initial VLAN that is starting, that is 128. Sometime you may be getting the question, what is the first subscriber VLAN? So that is the 128. So multiple subscriber are terminated, can be terminated at the ADSL port. That may be 24 port, 64 port, 72 port, 48 port at the type of the DSLAM like NSN, JT, Huawei type of the DSLAM. We are UT Starcom DSLAM. We are using in our broadband multiplay network. So we are having the different capacity DSLAM, and the different subscriber can be terminated. ADSL subscriber can be connected to these ADSL port, and DSLAM is multiplexing all connected subscriber and converting into a composite signal. That composite signal is known as the Q in Q VLAN or outer VLAN of the subscriber. The outer VLAN is configured at the upper network element, which is from where the DSLAM is connected, and subscriber and inner VLAN, that is the subscriber VLAN or subscriber ID. So the subscriber, so inner VLAN are configured at the subscriber port at which the subscriber is physically connected. So inner VLAN is the ID of the subscriber and outer VLAN is the ID of the access network element in ADSL, that is DSLAM. So there are two ID. One is the inner VLAN. Inner VLAN is the ID of the subscriber, and outer VLAN is the ID of the DSLAM. And up to BNG, that is the layer 2. And BNG can also work as layer 3. So up to BNG, the data communication take place in form of the outer or VLAN. You can say the VLAN. So that is the layer 2 network. Now, so DSLAM, you can go further. It is given in your topic or in syllabus. Digital subscriber line access multiplexer. The equipment located at the phone company central office, that is the CO. Subscriber DSL, that extra over data over existing copper telephone line is multiplexed into a single high-speed optical fiber Ethernet line during the upload, and subscriber data is demultiplexed from the stream received at the optical Ethernet port and forwarded to the subscriber, respective subscriber DSL port during the download. So you need to remember, you need to go through. So DSLAM is the multiplexer and demultiplexer. It is doing the multiplexing from the down to upside and converting into a composite signal, and it is demultiplexing from up to down and sending and converting the all subscriber respective subscriber data and switching to the subscriber port. It intermixes voice frequency signal and high speed DSL data traffic into a customer's DSL line, support incoming phone and data signal and direct from onto the appropriate carrier's network. Voice calls are sent to the PSTN, traditional telephone exchange, and data are sent to the DSLAM. DSLAM is connected to the internet backbone, access to World Wide Web and other application using the access and core broadband network element. So DSLAM is one side is connecting to the subscriber and other side it is connecting to the DSLAM, to the OC-LAN for rural broadband and Tier 1, Tier 2 switches in case of the urban broadband or in-city broadband. So this is the network architecture of the broadband. Okay. So presently we are having the bungee link connectivity. So bungee ring at maximum location, we are having the bungee connectivity. At some location, we are having the 10G. So this network RPR Tier 1, Tier 2 switches and OC line switches are being migrated, are going to be migrated, or some places it is already migrated on the MNG PAN switches, that is the PAN cow. So PAN cow is replacing PAN cow packet aggregation network, center office aggregation unit, which is replacing to the Tier 1 switches, and the PAN packet aggregation network that is switching is replacing to the Tier 2 switches. So PAN cow and PAN application are implemented on Sixtens 660, and OC PAN has replaced to the OC LAN switch, and OC PAN is implemented on the Sixtens 650. So these are the two types of the switches BSNL has procured from Messer Fiber Home in MNG project for providing or avoiding the bottleneck at the aggregation layer of the broadband multiplay network. The other network elements and connectivity will remain same. So 1G, it will in future 10G, then 100G, and in future 400G. As I have stated earlier, the distance between two Tier 1 and Tier 2 switches, that is the 40 kilometer. OCPAN. OCPAN, other city packet aggregation network element, which is replacing to the OCLAN switches. OCPAN switch is implemented on Sixten 650, which is procured in MNG PAN project of the BSNL. In MNG PAN project, BSNL has procured the two switches. One is the Sixten 660 and the other is the Sixten 650. On Sixten 660, we have implemented PAN cow, which is replacing to the Tier 1 switches, and PAN, which is replacing to the Tier 2 switches. And OC PAN is implemented on Sixten 650. This MPLS means MNG PAN, that is MPLS next generation packet aggregation network, which is MPLS TP based technology, multi-protocol label switching, transport profile based technology, which support SDN, software defined network, which support all types of the topologies, ring, mesh, or point-to-point, which provide highest switching time of 2 milliseconds in comparison of traditional RPR, that is 50 milliseconds. And it can provide multiple rings from a single BNG, where only single ring is available in RPR Tier 1, Tier 2 switches. So it can provide multiple ring and number of rings from the and even rings within ring. You can say rings within ring. So means bandwidth and redundancy is increasing tremendously in MNG PAN. And one more thing, capacity is also increasing, because whole RPR ring supporting only 4K VLANs. So 4K VLANs means 4K services along with the 4K means along with the different network elements are supported in the RPR ring. However, in case of the MNG PAN, each port in MNG PAN support 4K VLAN, and these 4K VLAN can be repeated on other port. So redundancy and means, and one more thing, it supports the layer 3 as well. Means there will be no need to configure the internet lead line in BNG if you are providing the internet lead line from the MNG PAN switch, OC PAN or PAN cow switch in future. Okay. So please go through. It will give the in-depth picture of the working of the different network elements. See here, CP is configured to send data, voice, video traffic as per the specific ATM PVC value, as I have stated initially. So between modem and DSLAM, there is a protocol that is known as the ATM is working. So 3 PVC for 3 services like VPN, IPTV, VPN over broadband. So how many services are going to be provided from the broadband connection? Similarly, same number of the PVC need to be configured in case of the FTTH broadband, which is TDM from the OLT to ONT or ONU, and TDMA from ONT or ONU to OLT. Can also support the jam or jam values are used to segregate the multiple services. Okay, and DSLAM here. Okay, so DSLAM aggregate all the voice, video, data, traffic, and multiplexes into a composite signal. This composite signal is known as the Q in Q VLAN. All connected subscriber data will be transported in form of the Q in Q VLAN, which is known as the outer VLAN of the subscriber. So inner VLAN is the ID of the subscriber and outer VLAN is the ID of the DSLAM. And RPR or OCLAN switches forward the traffic to the BNG. And in BNG maps the traffic to the corresponding context and forward the traffic to the layer 3 provider edge router with upstream VLAN tag. Okay, ultimate, the subscriber will be connected to the internet. Okay, now you will. So previous slide is giving in-depth functioning of each and every network elements and their connectivity. And the second slide, this is the will give in-depth understanding of the authentication, authorization process and the network elements and server involved for providing the authentication of the subscriber. When the username and password of the broadband service are configured in the CPE, then CPE will send a connectivity request to the SSC via this connectivity through the BNG. The first request will come to the SSC. SSC is not a data, is not having the database. Only it is handling the queries of the subscriber on behalf of the AAA server. So it is working as a middleman. So on getting the subscriber required, it simply forward to the AAA server. For completion of the authentication, authorization, and ensuring the subscriber accounting. In this physical server, only these 3 servers, authentication, authorization, and accounting are working. It is not having the data. Database is residing in the LDAP server. So AAA server will send the query to the LDAP server. LDAP on getting the subscriber request, LDAP will verify the subscriber username, password entered by the subscriber to the username and password kept intact in the LDAP server, and also verify the port binding. Port binding is having the two parameters. One is the subscriber ID, that is the inner VLAN of the subscriber. Outer VLAN, that is the ID of the access network element. And the NAS IP, network address server IP, that is the BNG IP address. So after verification of the username and password and port binding of the subscriber, it responds back to the AAA. So AAA, along with the flag of the AAA policy and details available in the AAA policy. So AAA will complete the authentication and authorization process and communicate to the SSC. Then SSC will communicate to the BNG. BNG, in conjunction of the SSC server, will assign a free IP address to the modem and enforces the traffic policy to the subscriber session for data download and ensure the differential speed plan of subscriber. It also ensures how much data is downloaded, how is remaining, and ensure the accounting of the subscriber. So next session, so their data traffic will be there. If any server, SSC, AAA, LDAP, will not respond to the subscriber query, or if they are not reachable to the subscriber, or any issue is persisting in any of the subscriber, all subscriber of the BNG will get the authentication error, that is known as the error 691. It will be encountered, it will be known if your modem is configured in the bridge mode. Otherwise, it will show no internet. No internet means no valid IP address is assigned to the modem. Means there is a authentication issue which can happen due to non-functioning of the any three server visible in the slide, or wrong username and password entered by the subscriber, or not matching the port binding of the subscriber. Error 691, that is the authentication error, can also happen if no free IP address is available in the BNG. Or you can say all pools, IP pool which are available in the BNG to be assigned to the subscribers, different subscriber, broadband subscriber, or adjusted. So these are the error 691 region. So you have to regularly monitor the utilization of the IP pool configured in the BNG, and you have to monitor the functionality of each and every server. If all subscriber, or if any of the server is not responding, all subscriber of the BNG will get the error 69. Or if there is a long queue of the authentication is available in SSC, then the subscriber will also get the error 691 or delayed connectivity of the broadband. Okay, so there is a billing session. So accounting is also happening. So if subscriber modem is disconnected, the IP address will be withdrawn by the BH. So that is the dynamic, the IP address allotment is happening by or being allotted by the BNG by means of the DHCP service in dynamic in nature. When it is free, it will be assigned to one subscriber and it is kept free by that subscriber. The same IP address can be assigned to the other subscriber. Okay. Now the one more error you can face in our broadband multiplay, that is the network error. And that is error 678. Error 678. So any issue starting from the subscriber modem to the BNG and their connectivity, the subscriber will face the error 678. That can also happen due to the wrong configuration of the BPI, BCI value in the modem, improper configuration in the DSLAM, or no proper VLAN is passed in the RPR TAR1, TAR2 switches, and no inner VLAN is configured in the BNG. The subscriber will get the error 678, which is known as the network error or configuration error, which can happen due to the wrong configuration of any network element starting from the subscriber up to the BNG. Okay. So these are the broadband multiplay provide convergence of the voice, video, and data services. That is the, I have already stated, multiplay broadband. This is the product of the BSNL for providing all type of the services. Any query, any thing required, you may communicate. I will also try the question bank of the broadband. You may ping on my WhatsApp number available in the slide, or can be available from the batch in charge of this project, this course. Okay. Or you may contact directly to me. So that is the AAA Play services, means providing the following services to the customer: voice, data, voice, IPTV services. So requirement of the customer and connectivity, telephone connectivity, computer with 10 or 100 Mbps Ethernet card, DSL modem, installation of point-to-point protocol over Ethernet software, broadband account username and password, which is provided on the provisioning of the broadband services to the subscriber. So this is the high speed, always on internet content based services: video on demand, education on demand, audio on demand, web conferencing, interactive gaming or games on demand, multiplay, multiple services, VPN on broadband, multiple services can be provided. We are providing VoIP services, VPN over broadband services by on a through the single broadband connection. Do's and don'ts, the first thing I suggest every person attending the class, please ensure the security implementation at the customer router and provide the disclaimer to the subscriber, because the customer is the owner or administrator of the broadband connection. We initially configure the subscriber modem and provide the username and password of the broadband service with Wi-Fi password. And you should have the disclaimer. You should have the means how to implement the security for wireless, how to implement the security of the WAN for unauthorized access through avoiding the unauthorized access of your broadband modem. I want to communicate clearly one thing very clearly. We are providing the public IP address to the subscriber modem for internet connectivity. So there may be the exposure of your broadband network IP pool to the public network. And if someone will know the public IP address assigned to the modem at that time, can have login remotely to your modem by default username and password if the subscriber had not changed. So that is the ban security. So there are two types of the security implementation for ban side security implementation. One is the ACL, access control list. So you need to create and activate the ACL at your router for a particular single IP address that may be a 192.168.1.2, from where you are accessing your ADSL or VDSL router or ONT. So that is the ACL implementing. This feature is available in all types of the modem and ONT. And second thing, there are the ACS, access control services, that are the HTTP, hypertext transfer protocol, which is working on port number 80, secured cell, which is working on port number 22, talent, which is working on the port number 23, and FTP, that is file transfer protocol for uploading the data to the modem or from the modem, file transfer protocol. So talent, SSH, HTTP, and SNMP, which is working on the port number 161. These are the protocol or services available on any ADSL router for remote management. So these protocol should be enabled judiciously on the LAN side. We are using the only HTTP protocol. We are only browsing to have the man-machine communication of the ADSL router through its IP address, that is 192.168.1.1. So this protocol should only be enabled on the LAN network, LAN side. No protocols should be enabled on the WAN side. WAN side is the link from the modem to the DSLAM. So you can see the LAN side and WAN side in the modem if you log in. So no protocols should be enabled on the WAN side, and your username and password, default username and password for accessing ADSL or FTTH router, you need to change. So access control and password management. So these are the three things need to be implemented, and there should be a disclaimer and procedure how to implement LAN and WAN security, WLAN security. And WLAN security enable and disable the wireless as per the requirement, hide the SSID, and MAC filtering. So these things you are doing at your home broadband connection or office broadband connection and need to be implemented and communicated to the subscriber as well. And disclaimer should be provided to the subscriber. So that is the important to enhance the security. So that is the username and password. So Any doubt, any clarification, you need to write in your chat box, or you can share, unmute yourself and let me know. For your study, I want to suggest you have to put the document which is provided by the BSNL for this LIC LDC exam. So that should be the base document for your study. Okay, so please go through that a PDF or document. I will make the question bank and will provide to you participant. Okay, so my number is on. My number is 9412000939. That is Naresh Singh. Okay. Or Naresh Singh 17@gmail.com is my ID. Okay. You can contact me on these. Okay. I will try to make the actually I was supposed to take the class on 1st of May, no, 1st of February, but due to some constraint, I was asked to take the class today. Okay, so thank you very much.
सर मेल एड्रेस रिपीट कर दीजिए सर.
nareshsingh17@gmail.com.
78.
17. Or feel free to contact me anytime for any query related to this broadband or your exam for this topic. Isn't it? Any doubt, any clarification, please let me know. Is it okay? Fine.
Okay, sir.
Should I conclude? Thank you very much, all participants and the organizers for giving me this opportunity to present you for you participants. Thank you very much. Have a good day. Thank you all.
Thank you, sir.
Thank you, sir.
Thank you all. K. Yadav ji. Thank you. Thank you. Thank you all.